Okay, so what I want to conclude with is how this framework impacts video quality of experience in the wild. So this is joint work with our colleagues at Telefonica, Juan Luis and Francisco Jose, and is based on a live pilot we did. So let me start with some context. Obviously, Telefonica is a global player. They have presence in 9 countries, and the trend is obvious. Everything is moving or evolving to full IP, whether it's pay TV and, of course, over-the-top internet. Telefonica here is both the video content provider and the video content distributor. So they're using their own CDN at these different locations. And naturally, they care about video quality of experience, and experimentation with new congestion control algorithms is one thing that has been on their mind. And the starting point here is the same, which is when you're sending traffic across all of these different points of presence, even in the same country, right? There's no reason to expect that the same underlying content delivery framework would be optimal across all of these locations and all of these different services, and that's actually not what we're seeing. And something that I think is interesting is that at some point, Telefonica actually tried switching between TCP cubic and Google's BBR. I don't know how many of you are familiar with these algorithms, but these are the 2 most widely deployed flavors of congestion control. And to their surprise, right, BBR actually performed worse than cubic in most locations, significantly worse, which is surprising, but it's not that surprising, given that, as I mentioned, different algorithms, one-size-fits-all congestion control algorithms fare best under different conditions. It turns out that for Telefonica's conditions, right, BBR was not the right fit. And what we did is we deployed our solution at several of their points of presence. I'm going to discuss results from Latin America, but here's the high-level architecture of the solution. It has 2 conceptual components: the edge, where real-time rate control decisions are made. Think of this as a software element residing where the content is. So the video cache or the CDN node, and it overrides whatever congestion control logic you have in place with this online learning congestion control framework. And then there's the back end. There's Compera Cloud, which is responsible for the longer-term customization. So this gathers statistics from the edge for the purpose of nudging the edge in the right direction across time, changing the congestion control logic based on the actual prevailing network conditions at these different locations. So we're looking here at 2 countries in Latin America. We'll call them LA1 and LA2. And this was A/B testing. We're looking at several POPs. Several of the servers in a POP are using our solution, and several are using Telefonica's original build. We collected layer 4 statistics, so packet losses, throughput, packet delays, and so on, the CDN logs, and also quality of experience performance scores from the video clients themselves. And this was across different devices, across different access technologies. And even before specifying some numbers, I want you to see customization at work. So what you're seeing here are 2 different subnets, a wireline one and a cellular one, at 2 different locations. And the x-axis is time. The y-axis captures different notions of quality of experience. The average video bitrate, the time spent rebuffering, both in terms of objective time and the fraction of video playing time. And over time, there's 3 different configurations of the edge, of the congestion control algorithm. As you can tell, in both locations, all 3 metrics were improved, right? So there's value to actually changing the way that content is delivered across time, because the video service running on top can make use of these better network conditions. And indeed, this has led to substantial reduction in rebuffering ratio. This is the average reduction, but obviously if you look at the users actually experiencing rebuffering, which are a non-negligible fraction of users, right, the numbers become much higher. This is true across all evaluated device types. And we're seeing substantial improvement also in terms of the video bitrate. Once again, the users suffering the most are of most interest to us. So the lower percentiles, because that is where churn and support costs and maintenance are more prevalent. Also, at some point, we become capped by the encoding ladder. Right? There's only so much that we can improve. But one of the interesting findings of the study was that we can also reveal to what extent the encoding ladder itself can be improved. Right? Because we're the ones sending the traffic, we know how fast traffic could theoretically be sent, right? To what extent higher video bit rates could have been supported. So to conclude, naturally, congestion control impacts video quality of experience. Right now, we're using one-size-fits-all solutions across countries, across services, across points of presence, across servers, across different IP subnets within the same server. I would argue that doesn't make sense. We would like to somehow tailor this behavior to what we actually care about, which is video quality of experience. And naturally, extending this approach to other types of content, to other types of regions, to other types of networks is of interest. Thank you very much.
Any questions for Michael? I have a couple of questions, but let me ask if anybody else has any. Well, I have two questions, Michael. First, you talked about this module that you incorporate onto the CDN where you override the existing congestion controller. How easy is it for the CDNs to do that?
So fortunately for us, it's easy in the sense that this is a hot update. You just need to change a specific kernel module, the one responsible for congestion control, and from an external perspective, it looks exactly like TCP. So you don't need to touch the network, you don't need to touch the end device, so you don't need to touch the end user at all. And it's a hot update. So you're not affecting ongoing connections, it just affects.
But this applies to all the traffic coming out of the CDN?
Coming out of that CDN,
okay.
Right. But within this traffic, so you can do this for different servers, and even for the same server, you can configure things differently for different IP subnets. Okay. So you can choose one behavior for one IP subnet and say a different behavior for another one.
Okay. And the second question is the central component. Is it really learning from the data coming from maybe just the Telefonica, or if you have other customers, you will be aggregating the data, or I mean, is there any privacy concern there, or
right.
Is there any?
Right. So far, so there's really two sources of data to the centralized component. There's the transport layer statistics that we collect ourselves and relay right. from the edge, and then there's whatever statistics our customer provides, which is typically CDN logs, and a lot of them also have presence at the client, say through Conviva or Ubora right. or Nice People at Work. At the moment, we're not mixing between customers precisely for this reason. Because of privacy reasons, everything is self-contained. I think once we gain sufficient confidence, we'll have to have a lot of anonymization and aggregation and differential privacy methods in place to support it.
If you did, do you think your learning would actually improve?
I'm sure it would. I'm sure it would. I mean, as with any machine learning algorithm, the more data you have, the better the situation.
Well, as long as the data is not crap, so.
As long as the data is not crap, right.
All right. Thank you very much. Oh, there's a question. Yes.
Hey, one more question. Since we all learned so much about Quick yesterday, I'm curious, is this all applicable to TCP, or have you done similar things in Quick as well? And does being able to do congestion control, like in the user space, open up additional possibilities there? Yeah,
thanks for this question. So yeah, we also have a working version for Quick, and we're actually also experimenting with a version for WebRTC, which also runs on top of UDP. From our perspective, Quick versus TCP is more of a technical detail because Quick obviously introduces a lot of novelty, but the congestion control element within it, right, is still pretty much what you use in standard TCP. So you may use Quick with Cubic or you may use Quick with BBR. So we're replacing specifically that part of the user
So
space.
I guess Dennis's main point is, since it's user space component now, with Quick, maybe deployment will be easier. You don't need to change the kernel update,
I see.
like kernel components
Yeah.
and things like that.
I think
So
that's-
it's a user space update, so.
Right. I think there's two sides to this because on the one hand, it's user space, so everything should be easier. On the other hand, it's not as well standardized as TCP is. So with the kernel, at this point, you can just tell me your operating system version, I'll give you a kernel module and everything works fine. Here, there has to be some type of interaction with
That's the whole point.
with the customer, but I think it's very doable. Thank you.
Any other questions? All right. Thanks, Michael.
Thank you very much.